So here we go, everyone. Thank you, Stephen, for the introduction, and let's get going. Okay, folks, so that was 15 seconds. If you are a professional if you're a non-music professional, it's very likely that 10 to 15% of you would have experienced tinnitus in those 15 seconds. If you are a music professional, then the actual numbers go a lot higher, and it can go as high as 57%. But tinnitus, that's what we've come here this evening to talk about. Well, what is it? Is it just that ringing in the ears that we see that's how it's described and shown to us when we see a movie, when there's a big explosion going off and we see the poor person stagger around and hear this whistling noise? I can assure you that isn't always the case, because at the moment my tinnitus is roaring, and it's not just bells ringing or a big humming noise. It's mine's a great, lovely sound of little animals running around. Well, that's what we're here to discuss this evening. First of all, I'll introduce myself. Stephen did a lovely job, and thank you for that. So you all know I'm an audiologist. I've been an audiologist for over 20 years. Did a degree in audiology, studied the ear for 4 years. Yeah, just the ear. That's I dedicated my life to it. Then about 10 years ago, after working in the NHS and the private sector and having the pleasure of being a tinnitus retraining therapist, working with people with special needs, and then specialising in working with people in the music industry, I got a real taste for the music business and decided to kind of leap boats and jump across to having my own studio, which I'm sat in tonight, and becoming a mastering engineer. In that time, I've also had the pleasure of writing, it was one of the first chapters to go in a music production book about hearing and ear care. And that went in the Dance Music Manual, the 4th edition. It's another chapter I've written as well in the 5th edition, which is out in the near future. And I'm really excited and proud to say that I've written a book on mastering, which is due to release in December, I believe, by Taylor and Francis. So a little bit about me and how I come to understand the fact that tinnitus and music production, engineering, audio engineering is all related. I thought we'd start the evening looking at some facts and figures, get the grisly stuff over with maybe first of all, and we'd look at the prevalence. And we're in the UK. I know there's some people experiencing this talk, not in the UK, but I'm going to give you some figures for the UK first of all. Approximately 18 million adults will have a hearing loss or tinnitus. Quite a significant number of people. As we get older, it's more prevalent. Over 50% of over 55s will have a hearing loss. And 1.2 million adults cannot hear conversational speech. Now, that is quite shocking. That is people missing out socially. It's affecting their lives dramatically. And sometimes they don't even realise because it's happened so slowly. So there's the first shocking figures, and that's just the UK. And these figures are very recent. I have put a resources slide at the end. So if you want to go on and look at the actual research that shows all this, it's research from around 2022, 23. So it is very recent research. We're here though mostly to talk about tinnitus. So I wanted to get you some figures on just tinnitus. So the average person in the UK, it's 1 in 7 that will have tinnitus, to over 7 million adults. Now, the interesting thing about this figure is it's 1 in 7. That might be we'll get 7 people in a room and one of them will report tinnitus. And that's today or this evening. Tomorrow, we'll get the same 7 people in a room and a different person will report tinnitus than they did today. And that's one of the interesting things about tinnitus. It's not always a static prevalence. It moves. You know, I have tinnitus. I don't have it all the time. Some people will have it all the time. Some people it comes and goes. And that's what makes it, for me personally, a really interesting subject and an interesting thing to treat and deal with. But globally, we want to know what the impact is. And globally, tinnitus affects 740 million adults. Took me a bit of time to practice saying that because it's such a large number. And of those 740 million, for 120 of them, this is a major, major problem. It's not just something they can just ignore. And because of that, it is actually considered to be a global burden. But we just don't have the research. The research isn't there. We have organisations doing research, British Tinnitus Association, there's universities in the USA, in different parts of Europe, in Australia, loads of really interesting research being done. It's still not enough. We still don't know enough about it. It's intriguing. I mean, I've been learning about it for over 20 years, still don't know everything. But we are audio engineers, and we're affected by it, and we're affected by it a lot more than, say, the average person out in the local supermarket. You know, the average person you'll meet on a high street. We are 4 times more likely to develop a noise-induced hearing loss because of our profession. Which then also means that we're 57% more likely to develop tinnitus. And this figure actually shocks me. This was a figure that was discovered by the Music Union UK, and 40% of UK professional musicians are affected with hearing loss due to our profession. That speaks volumes. I think it's something we should all consider, because that means maybe we're not looking after our ears, and it's something that we should do. Our ears are our most valuable work tool. Nature gave them us. They were free. You know, we spend, I know you can see possibly in front of me, I've got a nice amount of hardware. You know, £4,000 on this, 2,000 on that, £1,000 on that, £100 on a plug-in, £200 on a plug-in. You know, our doors, ears, they came free. And we don't look after them. So I felt that talking about tinnitus, we needed to talk about ear care as well. And to talk about ear care, then we needed to actually do a whistle-stop tour of the ear. I studied it, as I said earlier, for 4 years at university. I have friends that are doctors who studied the whole body for 4 years. I can't fit 4 years into this talk, but let's have a look and see what we can fit in. So the first bit we have is the outer ear, which we're all familiar with. It's the pinner on the side of our head. It's the cartilage that the pinner's made of. Then there's the ear canal going round. And as we all know, we've got the eardrum, tympanic membrane at the end. So in this whistle-stop tour, why is that bit important? Well, the pinner, first of all, that actually is a funnel. And I find that exciting and interesting that we have a funnel on the side of our head that guides sound, audio, down into that tube. Guides it into the tube. The ear canal itself is really short. It's 2 to 3 centimeters long. Obviously, the smaller the person is, a child or a small woman, you're looking at 2.5 centimeters, and a man of 6 foot, about 3 centimeters before you hit the eardrum. It's shaped like a letter S, and it's also sloping. So it slopes downwards to the outside. Why is that important? That's important because of cleaning. I've put this slide in because I have a real phobia about people using Q-tips. Q-tips, cotton wool buds, hair grips, the old-fashioned car key, door key, the finger, all those things are stuck in ears. I've just told you that your ear canal is only 2 to 3 centimetres long, and you're going to stick that in your ear. You shouldn't. That's the first thing I'll say. And everyone goes, yeah, but how am I going to clean my ear? I get wax and it all builds up and it doesn't come out. And I go, well, it does. Wax is actually, it has some amazing properties. Leave it where it is, unless it becomes your ear becomes occluded and it becomes a problem. It is a natural form of protection. It's antibacterial, antifungal, and it's got antibiotic in it. And it's actually, it is formed at the very first third of the canal. The canal is divided up, and at the very top you've got the eardrum, and the eardrum skin comes off that and then works its way down your ear. It naturally migrates down your ear canal, down the slope till it gets to the bottom third, where there's hair cells and there's a gland that produces earwax. And what the ear does naturally is the wax is, the gland produces its wax, it grabs hold of that dead skin, and the hair cells then pull it out. So it's all natural. So, no Q-tips, no, pen lids or awful things like that. Leave it alone. If you think your ear is occluded, then speak to a professional. They'll have a look, because we can't. They'll have a look. If it is, they'll advise you on how to get it removed. So that's the outer ear. We then go to the middle ear. The middle ear is the area that your tympanic membrane then joins 3 little bones that we all know about, the oscilles. And what happens here is sound comes in your ear, it's travelling through air, and we need to make that sound then be able to travel through fluid when it gets into the cochlea. And that's what your 3 little bones do. Those tiny little bones, they actually are mechanical, and they transfer that sound wave so that it can travel through fluid. And that's the magic for me in that area. There's also a muscle, a stapes muscle, which can lift those bones. So if there's a loud sound, it's a little form of protection. It does that. We also have the eustachian tube in the middle ear, which is when we go up a mountain and our ears go all blocked and we can't hear anything. And what we do is we swallow, or we sort of blow our nose, and it opens up a little valve in the eustachian tube and clears. And as adults, we can do that. Children sometimes can't do it as well as us, and that's because their eustachian tube is still quite flat and hasn't dropped down. And as you grow, it drops down. And that's why when children have glue ear, as they grow out of it. It's because their eustachian tube is dropping down. As I said, a bit of a whistle-stop tour. We'll move on to the next part, which is your inner ear. Your inner ear on that diagram, as you can see, it shows you the snail part, which is your cochlea. And it also shows you, you can actually see on that diagram, it's got the balance organ. I'm not going to talk about the balance organ today. It's a topic well on its own for me to go into. Just bear with me. I've got a screen that's about to turn off. There, back on. The joys of technology. So the cochlea, it is a bony structure, and it's full of hairs. It's got over 15,000 hair cells in it. It's let me show you what it looks like when we actually pull it out. This is when it's really exciting. If we were to pull the cochlea out and straighten it, I've got you some examples here that show you when a waveform comes in, what happens and where it would hit. When a waveform comes in, if it's high frequency, it hits the hair cells at the beginning. The middle frequency, as you can see, goes right across down to the middle, and then the low frequency, it has to travel right to the end of the little snail. And that's why we often get people who will use their high frequency sounds first. It's simply wear and tear. Those poor little hair cells, those 15,000 hair cells that are in the cochlea, they actually, have to move in the fluid every time a sound comes in. And when they move, they're linked together, and sometimes those links get tired, they break, and they fall over. We expose ourselves to loud noise. I mean, we work in the music industry, we go to gigs, we do things like that. We expose ourselves to these ridiculous sounds, and then we can't hear properly. And it's what we call temporary threshold shift. And it can be that the hair cells have fallen over temporarily, and then they'll stand back up. Sadly, that happens for a while, and then they stop standing up. And there isn't a magic pill yet. There's lots of talk on the internet about one, but there isn't one yet. So then the sound has still got to travel further. It actually then has to get to our brain. So outer ear, middle ear, inner ear, then up through the synapses, up to the brain. And actually it's interesting because when we hear sound, it travels from our right ear to the left side of the brain. And it has to travel through synapses. And there's again another problem that we can have where the synapses get worn out. And I always refer to them as being a jacket we've worn to the office for the last 50 years. And we've leaned on the office table, the desk, and we've got patches now in our jacket where we've worn it through. And that's what happens to synapses. The myelin sheath can get worn out slightly, and that can result then in us not hearing as well. And often when people are struggling to hear, it isn't always a case that they can't hear you. It's sometimes a case of them processing the sound. So another topic for another time, but yes, that's another thing where people struggle, and we need to consider that. So if you're talking to somebody who might have a hearing loss and they're struggling, don't necessarily talk louder, maybe just talk a little slower to them. I'm now going to move on because we did the whistle-stop tour of the actual ear. I'm going to now move on to the sciencey bit behind that, as in the actual audio bit. Now, when I became an audiologist, I learned all about decibels, and I learned all about HL decibels. So that's how we refer to sound and audio. And I know now that I'm working in production and mastering, it's a completely different type of dB. But what we did is, what audiologists have done is they took the Fletcher-Munson curves, which I know have been say disproved, that they're not completely accurate because they were done on headphones. So there's things in the research now that's looking at them. But we use them because what we did was we said, well, this is where somebody can hear. And as you can see on the slide, it's a curve. Well, audiologists can't work like that. We're simple creatures. So we use one of these. This is called an audiogram. And we converted that complex Fletcher-Munson curve into this reading. And no, it's not PlayStation symbols on there. I believe they're all the kind of symbols that people use on PlayStation. I'm too sad not to have done that. I was too busy with an audiometer. This shows what a normal hearing result is on an audiogram. And it shows the frequency along the top. And then as we move down, we go -10, 0, and then we go +10, +20, +30. And it took me, in fact, it still takes me time, because I have to think about decibels and things, because I think of pluses, and when I'm mastering, I have to think of minuses, and it sort of messes with my head a little bit. But when you talk to an audiologist, they'll talk in pluses, and they would want your hearing result to be 20 or lower. So, we're looking at the 20, the number, if as long as your results are 20 or higher up on that screen, so between 20 and -10, you've got a great result. If, though, you've got conductive hearing loss, which means that your hearing is affected in the outer or the middle ear, then you'll have this result, which has the little sort of heart, like sort of square, like square things at the top, and the circles are lower down and the crosses are lower down. And a conductive hearing loss it's a bit like having a duvet thrown on your head. So you can hear, but everything's kind of muffled because the cochlea can still hear and the hair cells work fine and it still gets to the brain, but there's a blockage. So that could be several different things. It could be earwax, it could be a cold, it could be a problem with the ocelles, the little bones could be broken. You could have a perforation in your eardrum, different things like that. We have a high frequency hearing loss, which says it quite clearly there where it is. That's when the person can't hear sounds above over like one kilohertz. And the demonstration I put there, that's a sensory neural version. So that's actually affecting the cochlea. And there's a low frequency hearing loss. These are really interesting hearing loss. As an audiologist, I found these quite fascinating in the fact that they are harder to actually give amplification to. They're quite difficult to amplify a client with low frequency hearing loss. Not easy at all, because I think there's so many people with high frequency hearing loss because obviously the first hair cells to get damaged at the high frequencies. So it's the low frequency hearing losses are much more difficult to actually amplify. But a challenge is something I've never walked away from and will always take on. So I used to actually deal with, if we got anybody in the practice who had low frequency, I got them. Talked about hearing, and I think it's important to mention why hearing is so important. We need our hearing to develop an auditory memory. As audio professionals, we need our auditory memory. We use it to create, so we use it in production. We use it to learn sounds, how to identify EQ, how to know if EQ needs applying, if compression's been applied. When we're listening, we should be able to identify all those things. We use our auditory memory when we're mixing and mastering because we'll have listened to maybe reference tracks or, listen to genres that clients have said, this is what I want to work towards. So we need to build an auditory memory, and I that is so important. And when I'm working with people, I always say that's really, really important. So this is why our ears are one of our most valuable tools. But now that we know what our ears are and where they sit and how we hear and how we listen, the main thing is tinnitus and it affecting our career as audio professionals. So who gets tinnitus? Well, it's actually equal prevalence in men or women. It doesn't matter. Tinnitus doesn't, discriminate. It doesn't care. It just gives it us. But it does care about is our age. Oh, well, there's the reports that show that anyway. There is increased prevalence in young adults. There's a prevalence in young adults of 10%. It increases with middle age, and then it increases more with older age. And there's also certain conditions which are also associated with it. And those are conductive hearing loss. So most people will have a conductive hearing loss, and that could be due to their wax, their glue ear, those things that I mentioned before when I was showing you what The ear was how the ear, the anatomy of the ear. And if you have a conductive hearing loss, then you can experience tinnitus. Meniere's disease can also make us experience it. Meniere's disease is quite a rare inner ear condition which affects balance and hearing. An acoustic neuroma can be a reason that's associated with tinnitus. Sensorineural hearing loss. General ill health. So if somebody is not feeling great, they can experience tinnitus. It's also drug side effects that can cause it. So just looking down that list, there's quite a few reasons why we could get tinnitus. And the sensorineural hearing loss, when we look at hearing losses, we often find people experience tinnitus because normally we live in such a busy, noisy world. And we have so many things that we can hear, and our brain is very busy. When we actually have a hearing loss, there is a silence. And the brain then says, what can I do? I'm bored. So what it does is actually it listens to what's going on. So it listens to our blood pumping, our heartbeat, our synapses firing, and things like that. And that's what we're kind of hearing in our tinnitus. That's a way of explaining it to people when I'm working with them. You're actually hearing your body doing things. And that happens so when people have a hearing loss. So what we would do is we would give a hearing aid. Drug side effects, when we're looking at that as an associated condition. Drug side effects, quinine, different types of antibiotics, some strong antibiotics have been known to cause tinnitus. So it's being aware of these things. When I studied at Manchester University, we had an awesome lecturer who was a tinnitus specialist, and he had a client who used to come in quite regular and who liked to have a gin and tea, a gin and tonic. And obviously there was the quinine in the tonic. And he actually ended up saying, well, the only way you're going to stop your tinnitus is you need to really cut back on the gin and tonic. The client decided not to. Decided that they'd have some different types of treatment instead. So types of tinnitus. We have constant rushing sounds. Like I said, the start of this, I mentioned that often in a movie, you'll see an explosion go off. The star of the show will be all staggery, and then they'll make it silent, and then they'll do this noise as the tinnitus. And that's the sort of constant rushing noise they always give you. It's not always that, though. Some clients complain of a pulsatal and rhythmical sound. Some clients will say it snaps or pops. And I've even had clients tell me that they can actually hear hymns. And there's also documented research that shows that. So we're all different. We all hear different things. I actually have the enjoyment of the sound I get is a ant, bug, creepy crawly moving around in my ear. And that's the sound I have. And the first time I heard it, I actually thought a creepy crawly had climbed into my ear, even as a healthcare professional and an audiologist experienced. I was like convinced I had a bug in my ear until a colleague looked in for me and said, no, there's no bug in your ear. You've just, it must be your tinnitus. And that's what it was. If you go and see a healthcare professional because you have tinnitus, and I do always recommend people get checked out by a healthcare professional, they will do some tests. Nothing to be scared of. They'll do a hearing test. If you've not had one already, and actually you should have if you're an audio engineer, because you should know what your baseline hearing is, a hearing test can be done. It's simple. It takes either 10 to 20 minutes, I'd say. If you're under 40, you should have one done every 5 years. If you're over 40, get one done every 2 years. So they'll give you a baseline hearing test. They might do an MRI scan. Depends whether they need to do extra research, whether it's one-sided tinnitus, things like that. They'll ask you questions, they'll fill out a questionnaire, they'll want to know how much it affects you. Does it bother you? Some people are never bothered by tinnitus, and that's why the figures when we were looking at them earlier, although they're very low in the general public, sometimes people actually don't report their tinnitus because it doesn't affect them. And there's also what some people will do is they will want to measure the actual volume of people's tinnitus, the actual level of it. And they'll also be looking, some people will look for the actual frequency of it and things like that. Not something that I do or have done. Well, I've worked with people that have done. Personally, it's not something that I actually want to do when I work with a client, because I think it kind of makes it a bigger thing. So once we've done the assessments, we then treat it. And we don't do things like that unless you're looking on the internet and the internet tells you that we do, and we don't. I found these on the internet, and they'll tell you anything on the internet. I'm not going to do that to any client that I work with, electric shock or whatever. It just seems bizarre. And I know there's a lot of research, and I think there's places in Australia and some places in America that are doing different things. But I'm not convinced. So treatments that I do think are probably going to work. Well, I have seen work as well. I've had some very positive results from amplification. If somebody has a hearing loss, they're suffering from tinnitus, give them amplification, gives them sound back in their environment, removes the tinnitus. Brilliant. Great. Talking therapies. They are brilliant. Talking therapies, as in cognitive behavioral therapy, they are brilliant. Often a client, when they understand what tinnitus is, they understand how the ear works, they understand why they have the tinnitus, what tinnitus actually is there for, how to ignore it, they learn about it, they can deal with it. Some clients use sound therapy. They come in different methods. You can have little hearing aids, which will give you a sound constantly. So they're not getting amplification, or they might get amplification and sound therapy at the same time. You can buy sound balls. Amazon sell things like that. You can put the radio on. With sound therapy, the way I've always used it is I've always had it slightly lower than the tinnitus. That then means the brain has to concentrate and doesn't tune into the tinnitus, but tunes into the radio or the music that I'm playing. So people use that. There are claims that there's medication. I have never used any form of medication. I'm not convinced yet that there is any medication. But there's research being done, and I don't give up. There's our contemporary therapies. I believe definitely in using anti-stress therapies. So teaching clients how to relax. Stress is a massive trigger for people's tinnitus. As mentioned myself at the start of this, I had no tinnitus before I started the presentation. So we started, I didn't. Then when all screens went blank, I had massive tinnitus. So learning how to deal with stress helps people turn their tinnitus off. And then there's the amazing internet cures. There's the videos. I don't know if I don't do social media, so I can't say what's on social media. I can say what's on YouTube, which I go on very rarely if I can help it. But it always makes me laugh when an advert flashes up with some amazing cure for tinnitus. Usually, I think it's something. I think the one I saw recently was something about wearing a pair of socks or something. It was just, yeah, it was interesting. Entertainment. Can we just always ignore tinnitus? Not always. There are times when I wouldn't ignore tinnitus, and you definitely need to speak to a healthcare professional just for a checkup. Never ignore tinnitus if it's only in one ear, because we have two hands, two arms, two legs. Well, we've got two ears. Tinnitus should be in both ears. If it's not in both ears, get it checked. Healthcare professional will tell you why. And also, tinnitus is serious if it is giving you suicidal thoughts or harming thoughts. You know, people have committed suicide through tinnitus. I mean, there are people in our industry that have committed suicide because of tinnitus. It should not be ignored. It is not something that is flippant, something that we can just, laugh about. I mean, we do laugh about it because we call it titinus or we call it tinnitus, and we give it all these silly, strange names and pronounce it very weirdly, which I chuckle at, and I try not to correct people. But it isn't always a joke. Tinnitus can be really, really, really sort of serious to some people and affect their lives dramatically. Those people should not be ignored. They should seek help, and people should offer them help. The other thing that's linked to tinnitus is hyperacusis, which a lot of people don't realise is associated with it. Hyperacusis is not liking loud sounds. So you might see somebody who's out and about who has hearing protection on all the time because they don't like loud sounds. Hyperacusis has a very unknown prevalence. People don't talk about it. They just accept it often. But it is often a sign of tinnitus, or somebody will experience tinnitus. And 90% of the sufferers of hyperacusis also experience tinnitus. But the only figures we've got is that we think it's about 2% of the UK population that have it. We've not got, very sort of cement sort of prevalence figures, but that's what we sort of think. Because of hyperacusis, I hope none of you experience it, but leading gently on from hyperacusis is the fact that we should all have hearing protection. And we should all be aware of sounds, how loud they are when we're working, and how many hours we should be exposed to them. I work in music production, and I would say that I very, very rarely have this music that I am working on higher than conversational speech. There's no need. If something sounds good at that level, it'll sound really good at a high level. I can hear better, I don't get ear fatigue, and I'm not going to damage my hearing. Obviously, there are some audio engineers who will be working in the live industry, and those people, you should have these values ingrained in your brain. On your mobile phone, there's no excuse for us all having a SPL meter. I have an app for it. They're easy enough to get. Use it when I'm out and about. I use it. I use it if I go to the cinema. I use it if I go in a coffee shop. And I'm that sad that I actually have an alert on my watch if it goes over a certain level. So my watch goes off. And I'm even sadder because I have a passion for bean to cup coffee. And when I'm making my bean to cup coffee, I wear hearing protection. But you might say that's a bit extreme, but hey ho, I'd like to be able to hear well into my 70s, 80s. So this is the actual levels that we can have and safe monitoring. And we should all have hearing protection. There are foam ones, there are little bone conduction ones that are not custom built. There are custom built ones. The custom built ones, wow, everyone moans about how much they cost. They cost about £150. Is that a lot to spend? No, a hearing aid will cost you about £3,000 to £3,500. A hearing aid will last you about 3 to 5 years if you're lucky. So if you're going to spend, you're going to moan about spending 150 quid on hearing protection, by heck, you're going to moan when you come to buy your hearing aids. So, hearing protection, everyone should have it. Hearing test, hearing protection. And I carry mine around with me. I mean, all right, I'm a girl, I have a handbag. But if I haven't got my handbag, I've got a rucksack. Hearing protection is always with me. Wear it even at the cinema. That is the whistle stop tour. It was a bit of a whistle stop tour. Do apologise for that. That's probably because I've got tinnitus roaring in an ear, so I'm trying to ignore it. Hopefully it's made you all aware of what tinnitus is, that it's not the same for everybody. We might not have it 24/7. We might only have it when we go to bed at night and try and go to sleep. We can deal with it. We can learn techniques to help us cope with it. It does not have to be doom and gloom. We can continue to work. I work very successfully as a mastering engineer. I am very happy in what I do. It is not the end of our career to have tinnitus. But what I will say is look after your ears. You only get one pair, no magic pill. We got them for free. Not much you get in this world for free. And thank you for your time this evening. Please feel free to email me if you've ever got any questions. Email's on the screen. And I have put my resources on the slides, so if anybody needs them. Thank you very much. Has Stephen got any questions he needs to throw at me?
Alex, thank you so much for that. That was a brilliant talk on what is a very, very interesting and well, frankly, sometimes quite emotive subject. So thank you very much, and some solid sage advice in there for everyone as well. So thank you once again, Alex. Really appreciate it, and thanks to everyone for their patience earlier on what was a slight technical blip, but I think everyone got back, which is brilliant. So thank you very much, everyone, for that. So. Yes, indeed. Questions. I have two currently logged on the Q&A. And I would invite people to use the question and answer thing if they have a question. If you can't access that, please feel free to use the webinar chat. I'll try and keep an eye on it as best I can. But Alex, first question, if I may, these all come from, well, they're tagged up as an anonymous attendee. So I don't know exactly who to thank for the questions, but first one, I have a constant tinnitus from a concussion that caused nerve irritation. I went into an anechoic chamber and it disappeared. I'm 21 and have perfect hearing plus no damage to my ears. Why is this? Very interesting question there.
Wow. Did the specialist, I take it a specialist did answer that. As in a medical specialist. Tinnitus is, as I mentioned, it is a very strange, bizarre thing. Stress, it can be that sometimes once somebody's heard tinnitus, it can take some time for them to learn the techniques not to hear it anymore. And that's when talking therapies are very good. Cognitive behavioral therapy is very, very good. So that could be why. It's just that you haven't learned how to tune out from it.
Makes good sense. Okay. Next question is with amplification. With amplification to get rid of tinnitus, does this increase the risk for further hearing loss?
No, amplification is when we do amplification, we actually use prescriptions. We're very, very careful when we give amplification to anybody with a hearing loss. We don't over amplify. So no, when you have a hearing test, the results, I mean, it's all goes into a computer. It's all done, digital hearing aids, and a prescription is put in. Usually it's an NL1 or an NL2 prescription, and which we use commonly in the UK. It depends which country you're in, which prescription they'll use. And no, amplification should never give you a worse hearing loss.
Brilliant. Okay. Next question. Once hearing loss begins, does hearing protection pause the progression of the loss, or will the loss progress through the rest of life?
That's a really interesting one. Okay, that is a little bit like If it's noise-induced hearing loss and you were exposed to a loud sound and that caused it, then if you then wear hearing protection, it should cause your hearing loss becoming worse. But I'm going to put a but in there in the fact that hearing loss can be a little bit like wrinkles. It's the best way I can describe it. So as we get older, some people will get wrinkles and some people won't. And hearing loss can be a little bit like that. Some people, their hearing will deteriorate as they mature, and some people won't. So I'm on the fence there. Sorry, can't give you a distinctive, definitive answer. If you always wear hearing protection to prevent any damage from external sounds. Will your hearing deteriorate as you mature? I don't know. You might get wrinkles, you might get grey hair, you might not. Sorry.
I like the wrinkles analogy. Okay. So I have a few questions of my own actually, if that's okay. I was busy scribbling
Yeah.
away. Also, I don't know whether this is common with anyone else, but I also found myself slowly turning the volume down throughout the presentation. I started becoming conscious of, and there wasn't anything to do with how loud you were on your end or anything like that. I was just wondering if I could possibly deafen myself with my laptop, quite probably, if I got close enough. Anyway, sorry. Again, if folks do want to ask a question, rather, some people apparently can't see the questions or answers, so please do use the chat if you want to. That's fine. I'm here to read them out. But while I've got you, Alex, if I may, I was wondering. Well, one thing that crossed my mind recently, I've seen a lot more SPL metering going on at gigs these days. And I wondered if perhaps they're slightly cheating in a way, because it looks like quite a few will flash red when they go over 100 dB SPL. But what I've found in my own experience is that live sound is dipping a lot of mid frequencies these days. So I'm wondering whether these SPL meters are actually dBA weighted and they're just pummeling through a load of low and high end to keep the actual SPL levels that they're metering down. Do you reckon that's good enough, or do you think we can't be using the dBA weighted scaling in order to assess how loud a sound actually is?
I mean, I've used it confidently in the past. I think that one of the first things is being aware of loud sounds. Often, what I will say is, as we mature or get older, we become more aware that we might lose our hearing. When we're younger, we're kind of blasé about it. So, if we can maybe educate people more, I would say that is one of the key things. And I would carry on using, if those are the meters that you've got on when you're working in live, you've got to, use what you've got. But I think I wish more people just were more aware, because they look at those meters as well and they go, oh yeah, it's red. Oh, I'll be fine.
No, absolutely, and thank you. I've noticed that there's a pile of questions just come in while I was busy posing that. Apologies, it took ages. Okay, so list. Not tinnitus, but recent hearing test shows hearing loss with a dip at 4K, but otherwise normal. How would I'm assuming this is a result that's come through. So a dip at 4K, but otherwise normal. How would a music professional adjust their workflow to avoid HL impacting a finished result? HL, I'm not convinced I
I
know.
think, I mean, what I can say, because I can't see the question, sorry.
That's okay. Oh,
What I would
sorry,
say,
sorry, Alex, just to rephrase. How would a music professional adjust their workflow to avoid hearing loss impacting a finishing result? Would that be a hearing aid or EQ, etc.? Apologies for that.
when you say finishing result, do they mean as in the piece of audio that they're working on, do you
I
think?
presume so, yeah.
Okay, so as an audio professional, first of all, you need to know what your hearing is. It's being aware that you might have a dip at certain frequencies, and then it might be you have to employ different techniques or maybe certain plugins to make sure that you're not overcompensating in those areas. I mean, this is why to me, it's really important that people who are just coming into the profession learn about their ears. Sadly, education isn't great on the ground at that stage on our ears and how to look after them. And that's why it's really important at that stage, because it's such a big impact. But yeah, you need to be aware of, if you've got a hearing loss, it's part of it would be having to be aware of the frequencies it affects. And that's when I've worked with clients with hearing loss, that's what we've talked about. We've said, well, you've got a loss at 6K and it goes down, or you're 7K and it goes down. And what they've done then is they've actually work with another person, so they might collaborate with somebody else to make sure that when they've done something, they have another set of ears listen to it.
Thanks, Alex. Now, a point of experience is noted on the next thing on the question and answer, and that is I'll read verbatim. I have noticed that my tinnitus has got worse after my cancer treatment, both chemo and the antibiotics they had to use for my sepsis episodes. I was told that one of the antibiotics used had a very small dosage threshold for damage. So I guess off the end of that, is that something that you've encountered as well in your practice, that you have particular drugs that can or won't do more or less damage depending?
Yeah, it is. I mean, one of the things that we need to all consider is we're all humans, we're all very individual. Medicine is, I remember chatting quite in a heated debate with some, consultants about this, and we were all chatting about it. And medicine is still kind of witchcrafty in a way, because we can give one drug to one person and they'll be fine, and give it to somebody else and they'll have a side effect. And that's why when we go and get medication, we get this huge piece of paper that tells us all these side effects. But yeah, I have dealt with clients and worked with clients that have had chemotherapy or antibiotics, and it has resulted in them experiencing tinnitus. But as I said before, tinnitus, clients do learn to either deal with it or learn to completely ignore it, and don't always experience it 24/7. So it doesn't have to be completely negative to us. It can just be there, but we deal with it. I mean, obviously, I did mention there are some clients that we need to be more aware of and very careful of. But yeah, it is. I mean, I have dealt with clients and they've had successful results through talking therapies and different things.
That's great. Okay, next one in. How are real life decibels, dBSPL, and the decibels in the audiogram related? In other words, how can the measured hearing loss be related to physical sounds?
Right. So earlier on, I showed you the Fletcher-Munson curve, and what we did is in the dBHL was we took the 0 for that, which is the funny shape, the bottom, and it's curved, and because of the way our ear is, we hear certain frequencies better than other frequencies. As we all know, we've got those resonant frequencies in the middle, the 1 to 5 kilohertz, which we're very easy to hear. And we know they're very easy to hear because that's when we go to, say, places like NAM, and we go on that floor where they're all showing us their new synthesizers. Everybody has done a preset for those frequencies so we can hear it. What we did was, as for audiologists, because as I said, we're simple creatures, is we actually made that line a 0. We pretended that all those readings are just 0 in HL dB. So I'm not sure if I answered. Is that the whole of the question, Stephen? Sorry, I might have missed.
That is indeed, you're
Sorry.
fine. That's perfect. Sorry, quick shout out to the person who posed the question where I got confused on HL being hearing loss. So Sean and also Jamie, thanks for keeping me right on that point. Okay, next question. How can we best get how can we best get the sound engineers at amplified music venues to decrease volume to safer levels?
Yeah, I had my microphone on mute then. You'd have heard me laugh. Um, education. It really is education. That's all I can say. People need to understand that loud is just exciting for a short time. But I mean, I went to NAMM and it was at 140, and that was when we were just waiting to get our tags to go around our neck. Too loud. Turn it down.
That's yeah, that's pretty loud. Okay. Um, is there a good way to figure out a baseline to keep your sound at when mixing, especially when you're wearing headphones? Or can you suggest a way to measure how loud your headphones are in order to manage your listening levels?
What I do is I always think of sound as conversational speech, and conversational speech is about 60 decibels. So you don't really need to have the level that you're working at higher than conversational speech. So if you haven't got a meter on a phone to measure it, then just think, well, somebody sat next to me and they're chattering. That's the level.
You know, it makes good sense. There's always a bit of a giveaway when you can't hear um, something that someone's trying to tell you with some level of background on the go. I heard one time a while back an engineer suggesting that if they couldn't hear the sound of their hands rubbing together in front of their face when they were listening to something, then it was too loud. That was a bit of advice that stuck for some reason. So yeah, next question is more of a comment, and I guess it can be commented upon in return. Mixing and mastering engineers refer to reference tracks all the time. Live engineers with hearing loss should retire.
Okay. Not sure what the can answer that.
I saw the reaction. Okay, next question. How would you deal with an engineer slash musician who has hearing loss and is convinced that a frequency needs to be boosted, but it is in fact too loud to the point of damage? But that's, if that's the way they like it.
Oh, as in, is that sort of as an engineer who's working with them and giving them it through headphones and that, do you think that means?
So a musician who actually suffers from hearing loss, but is convinced that a frequency that possibly they can't actually register is too loud in the mix, but they want to keep it that way because for them, I think it's working.
Um, mhm. That's a politics one.
Tricky one, yeah. That would yeah, that would be
Yeah, it's politics that. It's like, I mean, often it's best maybe just let them go out the room. Tell them they're
right.
not allowed in the room, and then that you'll make it perfect for them, or just do it for them while they're there and then do it right after they've left. Politics that. I
Yes,
can't get
yeah.
into politics.
No, fair enough. Best avoid it, huh? All right. Okay. I do have a couple of scribbled down questions. I'll do a last shout out to the folks who are here to post some questions. There's a few points coming through, but just quickly from myself. You're now forgive my ignorance here. You station tube. Um, does that connects your middle ear to your throat? Is that correct?
Yeah, it's down near the back of the nose. Yeah.
Yeah. So when that gets blocked up, does that have an impact on the way your the transfer of sound through the bones?
Yeah.
Um,
So if you've got glue ear, which is what that would be,
so
so
that's
that's
actually glue
mucus
ears
in the middle
on
ear.
the
Is that
middle
what you
ear, so
mean?
it's the inside.
Sorry?
The glue ear actually occurs on like behind the tympanic membrane then.
Yes.
Right. Okay. Okay.
Yeah. So it's mucus that's in the middle ear and it isn't
Mm.
draining out through the little valve at the bottom.
And can that cause tinnitus? Is that
Yeah, because you can't hear properly, then
right?
people can experience tinnitus because the brain searches for other sounds. So it will listen to your heartbeat or your blood pumping
Right.
or your electrodes firing.
Okay. Cool. Um, low frequency loss, is that more rare than high frequency loss?
Yes, it is. It's often it's not always reported either. Some people tend not to report it as much, but yeah, because high frequency loss is more common because those high frequency hair cells are at the start of the cochlea. So every time you hear a sound, whether it be low, mid, or high frequency, the hair cells move.
So I've just had another question come through. Just to clarify, what causes low frequency loss?
Low frequency loss, it can be caused, it could be through overexposure to, so it could be noise induced, it could be drug induced, it could be an injury, it could be wear and tear, any of them. It could be a defect, you know, when you a birth, you know, it's a genetic birth thing, any of those things.
Cool, yeah. And then a couple of points have been raised in the chat about the use of traffic light systems. Um, So the ones that have been alluded to, I believe, are ones that I actually remember as well. And they light up in your studio or in your live room when things are getting too hot. So just I remember them. They were very useful. And again, just another sort of tag on to the previous question. I do apologize about this. It's coming through out of sync. The with reference to low hearing loss, is this damage to the cochlea specifically?
Not always, no, because you can experience low frequency hearing loss if you've got a conductive loss. So that's just sound not getting through to the cochlea. So it could be the low frequency sounds that aren't getting through.
Right. Okay. Yeah. Makes sense. Um, just out of curiosity, is there a lot of is there any work on how ultrasonics can damage your hearing?
Oh, there might be. There possibly could be. I'm going to put my hand up and say I'm not sure on that.
No,
I'm always reading different papers, but I'm not sure. Sorry.
no. That's absolutely fine. Okay. Right. Well, I have, with the help of several people, thank you very much to everyone who's clarified things for me, and asked questions. I thought I had reached the bottom of the questions, but one has just come through. We got time for one more, Alex. Are you happy for one more?
Yeah, that's fine.
Brilliant. Okay, one more it is. Um, okay.
Only
Uh,
if it's easy.
it's a technical one, I think.
Mm.
Can a blocked ethmoid sinus cause hearing loss or tinnitus?
Kind of what?
An ethmoid sinus. I'm gonna admit
Mm.
I've never come across an
Do you
ethmoid
know?
sinus either.
No, I don't know what that and I mean there's so many sinuses on the face.
There, yeah, indeed.
But
It's a bit of a
so
network.
no, I've not heard of any of the sinuses on the face affecting. But you see, tinnitus, it could be pressure. If there's tinnitus, I mean, you can have something wrong with the back of your neck and that can cause tinnitus. So you could
Makes
have
good
something wrong with the
sense.
muscles there. So if depends where that sinus is.
Right, yeah, no, that does make good sense. So yeah, if it's basically pushing somewhere where it shouldn't be pushing, then yeah, it's
Mm.
effectively the same thing. You're just exerting pressure
Yeah, and the
somewhere.
thing is, if you've got something wrong like that, that could actually then give you stress. And so,
Mm,
like I said earlier, general ill health can actually, you know, other things can make you feel as though you're experiencing, could bring on tinnitus.
yes, yeah, no, that makes good sense. Okay. Yes, just a comment come through. There's you know, I think I can sympathize with this as well. You can almost force tinnitus to occur, depending on what you're doing with your face, be it yawning or clenching teeth, is the one that was brought up in the chat. So yeah, many routes to having tinnitus. Yeah, but fantastic to have learned and insights on it. So, Alex, thank you ever so much again for a fantastic presentation and for a fruitful Q&A session. Very much appreciated. Um, and with that, if all the thanks are coming in through the chat, can you see them, Alex?
Yes, I can actually now. Yeah.
Perfect.
Yeah. Thank you
Perfect.
everyone for
Perfect.
attending and for being so kind to me, especially after having technical issues at the start.
No, it's yeah, very much appreciated, Alex. It was a pleasure having this session and hosting. So thank you very much indeed. It's always a bit weird over Tinterwebs not to have a round of applause at the end of a session, but as you can see, all the thanks are coming in. So a very much appreciated talk. So thank you once again, Alex. And I think all that's left to do is to sign off. So brilliant.
Thank you. Thank you very
Thank you.
much.
Thank you everyone for being here. Alex, thanks again. Until next time.